Humans exist in a cosmos filled with dazzling lights. Thousands of brilliant stars are visible to the human eye on a clear night. However, these stars only represent a small portion of our galaxy, the Milky Way Galaxy. Farther than that, the universe is illuminated by millions of other clusters, all having countless stars. Because what exactly precedes all these stars? And also, how did millions of such spectacular objects emerge across the infinite universe? Hello there, and welcome back to the Discover Space channel, where we explore the cosmos from its origins to its possible end. Subscribe if you haven't already, and let's get on to the video. Based on the Big Bang Theory, time and space began approximately 13.8 billion years ago. Everything we see today's fundamental components exploded into life. Nobody knows what happened before this point. It is the breaking point in our comprehension of the cosmos. Considering the uncertainty about how everything began, researchers have pieced together an approximate timeline of the important events that occurred following this extraordinary occasion. The Big Bang, according to popular belief, was not an explosion in space, but instead a moment when the universe was immensely hot and dense, and space began to quickly expand across all directions simultaneously, faster than the speed of light. The cosmos might probably turn opaque soon after. This must have resembled a hot, dense soup of elements such as protons, neutrons, and electrons. When the cosmos began to cool, protons and neutrons began to emerge into little units known as nuclei. Given these extraordinary circumstances, the material might have been dispersed throughout the entire universe like a thick fog, spreading all the light that had previously existed. As the universe proceeded to cool after approximately 380,000 years ago, the nuclei inevitably drawn electrons, converting those into neutral atoms, enabling light to move freely for the very first time. Recombination, the name given to the procedure of particles pairing off, marks the transition of the universe from opaque to transparent. Because it regularly collided with free electrons in the initial opaque universe, light had previously been prevented from moving freely. Light was no longer constrained and could now move in straight lines because the free electrons had been bound to the protons, forming neutral atoms. It thus set off the Big Bang's flash of light, which is still visible today as the cosmic microwave background, the first possible image of existence in the universe. The universe was revealed in this image of the cosmic microwave background, which was taken only about 380,000 years after the Big Bang. When we look into the cosmos today, the constellations, galaxy clusters, celestial bodies, and other astronomical objects we see did not just appear. Even the earliest stars in the earliest proto-galaxies didn't start to ignite for hundreds of millions of years. However, there was a moment when the universe was pitch black before the age of stars. The period following the universe's transition to transparency, but before the first stars were born, is known as the cosmic dark ages. For a few 100 million years, the universe was pitch black. The universe, however, was not completely of nothingness. After the Big Bang, matter started to group together, as well as attract more and more matter with gravity. Subsequently, a massive structure known as the cosmic web began to span the empty, dark expanse of the universe. The intertwining strands of dark matter, a mysterious and unidentifiable substance, may have also contributed to the formation of these massive strands of gas. The first stars, the predecessors of our Sun, ignited within these strands of gas. The dense gas in these regions began to break apart as it got denser and denser. In the densest places, the gas got quite hot. That nuclear fusion reaction started. The birth of bright stars then appeared out of the night. The universe was at last made visible. Huge objects that were almost entirely composed of hydrogen and helium, the elements that were created as an immediate outcome of the Big Bang, were likely the very first stars to awaken the universe. The heavier components discovered in today's stars, such as oxygen, nitrogen, iron, and carbon, would not have been present in them. They burned with such intensity that they blazed bright blue, with a power of even more than 1,000,000 suns, and were probably several hundred times more gigantic than the sun. They would have quickly depleted their fuel source because these stars were probably very massive. For instance, the estimated lifespan of a star with 60 times the mass of a sun is less than 1,000,000 years. This may indicate that the earliest stars, referred to as the population 3 stars, ran out of fuel a long time ago and exploded in a spectacular cosmic event known as a supernova. They are now only visible traces such as neutron stars or black holes. However, when they perished in the supernova explosions, they might have been responsible for producing the first materials for the population of stars after them, known as population 2, which has a low percentage of metals. Astronomers refer to anything heavier than hydrogen or helium as metals. The metal-rich population 1 stars that we see today were subsequently born from these population 2 stars. There have been trillions of stars ever since the initial ones formed, but among all of them, ours is perhaps the most distinctive, the most remarkable, perhaps. How so? We know that the Earth is the only place in the universe where life can exist. And also, in our particular instance, advanced life that is capable of studying the universe and figure out exactly what might have taken place throughout those initial stages that ultimately led to our own existence. That is because our star, the Sun, nurtures Earth. This is the impressive cosmic link that unites all of us. After all, the debris of these historic stars is from which all of humanity have originated. Well, that is it for this video. Thank you so much for tuning with us for another cosmic adventure. Comment below what other cosmic adventures you would want to explore next, and we shall see you then.